In this video, I'm going to be taking a look at the Where is the Horizon IGCSE modeling task. Right, so that's the part B, second part of the paper 6, and it's from June 2015, it's version 2. I'm going to go question by question, so this will be in separate videos. And what this task is about the relationship between the distance in horizon to the horizon, y kilometers, and the different heights above sea level, right, in meters. So if you're 1 meter above sea level, you are 3.6 kilometers from the horizon. So imagine yourself standing and looking at the horizon off in the distance. Maybe you're looking at a sunset or a sunrise. And if you're 2 meters above sea level, then you're 5 kilometers straight line distance away from that horizon. Yeah? 3 meters above sea level means 6.2 kilometers from that horizon. Now, I've already gone ahead and sort of plotted the points here because question 1A asks us to plot the points given in the table and indicates that the point 2,5 and 5,8 are plotted for me. All right, so if I just go back to that graph, excuse me from flipping back and forth, I've plotted in those points. The only thing that I want to say about that is that if you're going to plot the points, say 3 and 6.2 as an example, we want to make sure, obviously, that we, plot 3 and 6.2. Yes, fine, but we want to make sure that we're following the scale that's given, especially on the y-axis. And you notice that every whole number is split into a set of 5, which means that this line here is 6. Then it's 6.2, 6.4, 6.6, 6.8, and 7, right? So 6.2 actually ends up 1 mark above the 6, right? And one common mistake can be to assume that each of these ticks means 0.1 instead of 0.2. So we want to make sure that we sort of follow that. So that also means that 4 and 7.1 is going to end up somewhere between the 7 and the 7.2. So that's why that dot was drawn in between. You just want to make sure that you plot that accurately. So we have our graph. And then, so that was question 1A. Question 1B says, the simplest way to model the data is with a straight line, right? So already I'm starting to think of, what kinds of straight line equations do we have? We've got y equals mx plus b. We have the slope point form that we looked at that can also help us. We do have standard form too, but we know that standard form is not necessarily useful. It's good to have in our back pocket, just in case. So on the grid, draw a straight line passing through 2,5 and 5,8, and then find an equation of that line. So I'm going to go over to my page here and get my trusty ruler, and I'm going to draw a straight line through the 2 points marked as X, the 2 points that were already plotted for me. Okay, there we are. I might draw that straight line all the way across, and especially to the y-axis, right? Just in case that gives me any indication. It looks like it's possible that the y-intercept might be 3, but I'm not necessarily going to conclude that. And I think to myself, how am I going to find the equation of the line? Well, I can use y equals mx plus b to do that, but I'm going to need to use the points to find the slope first. And so I would name the points x1, y1, x2, y2, because I'm going to use my formula y2 minus y1, x2 minus x1, right? Now you might be able to do this sort of in your head, that's fine, right? But my y2 is 8, x2 is 5, minus 5, minus 2. So I've basically just positioned y2 into the equation there, right? x2, y1, x1, and remember that you could swap these around and you could have 2,5 here and 5,8 here, right? You'd still get the same slope. I'm going to get 3 over 3, and that's just a slope of 1, right? It's just a slope of 1. So then into y equals mx plus c, or plus b, whatever, I am going to get my slope of 1, and then I'm just going to pick a point, 2,5, substitute it into the equation, and solve for my y-intercept. Subtract 2 on both sides, and I'm going to get a y-intercept of 3. So therefore, y equals mx 1x plus 3. That's my equation. That's my equation. Okay? I could also have used slope point form. So use my 2, 5, right? And substituted the y value into there. After finding my slope, put my slope as m, and then x minus and the 2 x coordinate value, and then sort of simplified this, and I would have gotten my same equation instead of sort of solving for the y-intercept, right? So it's y minus 5 equals x minus 2. I add 5 to both sides, and I get x plus 3. Okay? So slope point form can also help us to directly find the equation. This method here, we solve for the y-intercept, and then we have to rewrite the equation when we're done. So either way is fine. Either way is fine. Okay? Using this model, what is the distance to the horizon when it is at sea level? Well, we remember, right, that the distance to the horizon is y, and the height above sea level is x, right? So what is the distance to the horizon when it's at sea level? So at sea level, will be x equals 0, right? That's going to be a height above sea level of 0. Height above sea level of 0. So we're literally going to substitute that inside, or you might already notice that that's the y-intercept, and that's 3 kilometers. That's the y-intercept that I suspected we had all along. So there we are. Okay, and that's question 1. See the next video for question 2.